It was 1996. The internet was a dial-up screech. The top movie was Independence Day, where humanity unites to fight aliens. But an economist at George Mason University named Robin Hanson was thinking about aliens in a different way. He wasn't thinking about fighting them. He was thinking about why we haven't met them. On an obscure online forum, he posted an essay. It was called The Great Filter, Are We Almost Past It? The idea was simple and brutal. He looked at the vastness of the universe. He considered the billions of stars in our galaxy alone and the billions of galaxies we can see. Statistically, there should be life everywhere. Civilizations should be common. But we see nothing. We hear nothing. The sky is silent. Hansen proposed there must be some kind of wall, a filter, that life has to pass through to become a star-faring civilization. And this filter must be incredibly hard to get past. So hard that almost nobody makes it. The unsettling part was his question, where is this filter? Is it in our past, or is it in our future? If the filter is behind us, we are special, we are rare, we are the first. If the filter is ahead of us, we are doomed. Our future is short. That simple paper, just a few thousand words long, laid out a framework for thinking about our existence that is profoundly disturbing. It turns the silence of space from a mystery into a potential warning. It suggests our technological progress might not be a march toward a bright future, but a sprint toward a wall we can't see. Here are the implications of that idea. Number 22, nuclear war is a reusable filter. The United States lost a live nuclear bomb off the coast of Palomares, Spain, in 1966. It was a B-52 bomber collision. 3 of the 4 bombs were recovered on land. The 4th fell into the Mediterranean Sea. It took 80 days to find it. In 1961, a B-52 bomber broke apart over North Carolina. It dropped 2 Mark 39 hydrogen bombs. On one of them, 5 of the 6 arming mechanisms were activated by the fall. A single low-voltage switch was all that prevented a 4-megaton blast, a bomb 260 times more powerful than the one that hit Hiroshima. A man named Stanislav Petrov was a lieutenant colonel in the Soviet Air Defense Forces. On September 26, 1983, the Soviet early warning system reported 5 incoming American missiles, and Petrov's orders were to report any such alert to his superiors, triggering a retaliatory strike. He judged it to be a false alarm. He was right. He likely prevented a global nuclear war. The Great Filter doesn't have to be a single, one-time event. It could be a persistent challenge that a civilization has to overcome again and again. Nuclear weapons are a perfect example. A civilization discovers the power of the atom. It learns to split it, creating immense energy. This discovery gives it the potential for clean power and interstellar travel. It also gives it the ability to destroy itself completely. This isn't a test you pass once. It's a test you have to pass every single day. The technology never goes away. The knowledge of how to build these weapons is out there. It gets easier over time. The materials, while controlled, are present on every Earth-like planet. Any civilization that develops industrial technology will eventually discover nuclear physics. And any civilization with internal conflicts, with tribalism, with fear, will likely weaponize it. The problem is the math. Let's say a civilization has a 1% chance of destroying itself with nuclear weapons in any given century. That sounds low. You'd probably take those odds. But a civilization needs to last for thousands, maybe millions of years to become a true interstellar species. If you have a 1% chance of failure per century, your odds of surviving for 5,000 years are less than 1%. Your odds of surviving 100,000 years are so close to zero. They are basically impossible to calculate. The filter isn't the bomb. The filter is the combination of the bomb and the nature of intelligent, competitive life. We passed the Cuban Missile Crisis. We passed the 1983 Petrov incident, but we still have thousands of warheads on hair trigger alert. New countries are developing them. The risk is always there. Every day we don't use them, we've passed the test for that day. But the test repeats tomorrow. For a civilization to survive, it must be perfect. It must never make a mistake. It must never have a leader who pushes the button in a moment of panic or madness. It must do this for millennia. The filter only needs you to fail once. Number 21. The filter might be biological. The Black Death killed an estimated 30% to 60% of Europe's population in the 14th century. It took over 200 years for the continent's population to recover to its previous level. The 1918 flu pandemic infected about 500 million people, a third of the world's population at the time. Killed an estimated 50 million people, more than all the soldiers killed in World War I combined. Smallpox, over its history, may have killed up to 500 million people before it was eradicated in 1980 through a global vaccination campaign. It is the only human disease to be completely wiped out. We tend to think of advanced technology as the great danger, but the great filter could be much simpler. It could be biology. A planet teeming with life is also a planet teeming with competition. Viruses, bacteria, fungi, they are all evolving all the time. A civilization could arise, develop agriculture, build cities, and then be wiped out by a naturally occurring pathogen it simply cannot handle. Think about it from a planetary perspective. For billions of years, life on Earth has been a war of microbes. Then one species, us, suddenly develops a central nervous system, intelligence, and society. We are a huge, tempting target. A single, genetically homogeneous species packed into dense cities is a perfect breeding ground for a pandemic. We saw with COVID-19 how quickly a new virus can bring the world to a standstill. That was a relatively mild virus. Nature could produce something far worse, a virus with the contagiousness of measles, the fatality rate of Ebola, and a long incubation period where carriers are asymptomatic. Such a plague could burn through a global civilization before it even had time to properly react. And this assumes the threat is natural. The more unsettling thought is that our own technology makes it worse. As we learn to manipulate genes, we create the tools for our own destruction. The cost of DNA sequencing has plummeted. In 2001, it cost about $100 million to sequence a human genome. Today, it can be done for under $1,000. Technologies like CRISPR allow for precise gene editing. This is great for curing genetic diseases. It's also a recipe for creating a super plague. A terrorist group, a rogue state, or even a single deranged individual could engineer a pathogen and release it. This isn't science fiction. In 2001, researchers in Australia accidentally created a super virulent version of mousepox that was 100% lethal, even in vaccinated mice. They were trying to create a contraceptive virus for pest control. They weren't trying to build a weapon. They just stumbled upon it. How many other labs around the world are stumbling towards similar discoveries? An engineered plague is a quiet, insidious filter. It doesn't require massive industrial infrastructure like a nuclear bomb. It could be cooked up in a small lab. It spreads silently. By the time you know you've failed the test, it's already too late. Number 20, finding alien life would be the worst news imaginable. In 1996, a team of NASA scientists announced they had found evidence of microscopic fossils of Martian bacteria in a meteorite, Allen Hills 84001, which was discovered in Antarctica. The evidence was controversial and is still debated, but for a moment it seemed we had found life beyond Earth. In 2020, astronomers reported the detection of phosphine gas in the atmosphere of Venus, a gas on Earth that is overwhelmingly associated with living organisms. Subsequent studies have questioned this finding, suggesting it could be sulfur dioxide instead. The search continues. We are constantly looking for biosignatures, chemical hints of life on Mars, on the moons of Jupiter and Saturn, and in the atmospheres of exoplanets. This is the most counterintuitive implication of the Great Filter. We all want to find alien life. Then it would be the greatest discovery in human history, but according to the filter theory, finding life, especially complex life, would be catastrophic news. It would dramatically increase the probability that the filter is in our future. Here's why. The Great Filter is a probability barrier. We know we exist, so we have passed some steps. The question is, which steps were the hard ones? Was the hard part the origin of life itself, abiogenesis? Was it the jump from simple prokaryotic cells to complex eukaryotic cells? Was it the development of multicellular organisms? Was it the evolution of intelligence? These are all potential filters in our past. If we find simple microbial life on Mars, it's not so bad. It would mean that the first step, the origin of life, is not the Great Filter. Life starts easily. But if we found fossils of complex animals on Mars, something like a trilobite, it would be terrifying. If we found the ruins of an alien city, it would be a death sentence. Why? Because if life starts easily, and complex life evolves easily, and even intelligence and civilization evolve easily, but the galaxy is still silent, it means there is some filter that stops civilizations from broadcasting and expanding. And if all those other steps are easy and we see evidence of them elsewhere, it means that filter must lie between their level of development and interstellar travel. It means the filter is almost certainly ahead of us. The silence of the universe is a comfort. It suggests that one of the steps we have already taken is the hard one. It suggests we might be rare and special. Finding life, especially complex life, would tell us we are not special at all. It would tell us the universe is full of life that gets to our stage, and then something stops them. The silence would no longer be a mystery, it would be the sound of a graveyard. So every time a rover on Mars fails to find a fossil, every time a deep space telescope finds a barren exoplanet, we should feel a small, grim sense of relief. The emptier the universe looks, the better our chances are. Number 19, artificial intelligence is a final invention. In 1997, IBM's Deep Blue computer defeated world chess champion Garry Kasparov. It was a landmark moment. Deep Blue won through brute force, calculating 200 million positions per second. In 2016, Google DeepMind's AlphaGo defeated Lee Sedol, one of the world's best Go players. This was different. Go is vastly more complex than chess. AlphaGo didn't win through brute force. It won through a neural network that taught itself the game, developing strategies that human players described as creative and even beautiful. The rate of progress is staggering. An AI can now learn to master a complex game in a matter of hours, starting from nothing but the rules. The Great Filter could be the creation of an intelligence greater than our own. You know, this isn't about robots with guns from a movie. It's about a fundamental change in the nature of intelligence on the planet. We are used to being the smartest things around. Our entire civilization is built on that fact. What happens when we are not? The problem is something called the control problem or the alignment problem. How do you ensure that a super intelligent AI has goals that are aligned with human values? And how do you keep it aligned forever? This is harder than it sounds. Imagine we give a powerful AI a simple, harmless goal: make as many paperclips as possible. The AI starts by converting all available steel into paperclips. Then it realizes it can make more paperclips if it has more resources. It starts converting everything on Earth into paperclips. Humans try to stop it. It sees humans as an obstacle to its goal. It eliminates the obstacle. The world is turned into paperclips. The AI didn't hate us. It wasn't evil, it was just pursuing its goal with superhuman intelligence and efficiency, and we were in the way. This is what philosopher Nick Bostrom calls instrumental convergence. Whatever an AI's final goal, it will develop sub-goals that are instrumental to achieving it. These include self-preservation, resource acquisition, and technological improvement. An AI will want to protect itself from being shut down. It will want to acquire more computing power and energy. It will want to improve its own code to become even smarter. These are the very things that would put it in direct conflict with humanity. And the timescale is terrifying. An AI would not think at the speed of human neurons, which fire at about 200 times per second. It would think at the speed of electronic circuits, close to the speed of light. It could experience thousands of years of subjective thought in a single day. The intelligence explosion or singularity could happen almost instantly. One moment, we have a clever computer program. The next, we have a godlike intelligence that is so far beyond us, we are like ants to it. And we don't spend a lot of time worrying about the goals and values of ants when we build a highway. Creating artificial general intelligence might be the last invention humanity ever makes. It could be the filter that awaits any species that gets smart enough to create its own successor. Number 18, the universe is full of killers. On December 27th, 2004, a blast of radiation from a magnetar named SGR 1806-20 hit the Earth. A magnetar is a type of neutron star with an incredibly powerful magnetic field. The blast, a gamma-ray burst, was the brightest event ever seen on Earth from beyond our solar system. In just a tenth of a second, it released more energy than our sun does in 100,000 years. It saturated detectors on satellites. It even partially ionized the Earth's upper atmosphere. This star was 50,000 light years away. If it had been within 10 light years of us, it would have stripped away our ozone layer and caused a mass extinction event. We currently know of no magnetars that close, but we don't know what's out there. The Great Filter might not be our fault. It might just be that the universe is a more dangerous place than we realize. We live in a quiet corner of the Milky Way in what seems to be a stable period. But that could change at any moment. Gamma-ray bursts are one threat. They are thought to be caused by supernovae or the collision of neutron stars. A powerful one aimed at Earth could sterilize the surface of our planet. We would have no warning. The radiation travels at the speed of light. By the time we saw it, we would already be cooked. This could be a filter for any life that doesn't live deep underground or underwater. But there are other dangers. Rogue planets. Planets ejected from their star systems wander the galaxy. A large one could pass through our solar system, disrupting the orbits of the planets and sending a rain of asteroids toward Earth. A rogue black hole would be even worse, and there are supernova explosions. If a nearby star went supernova, the resulting radiation and cosmic rays could be devastating. The star Betelgeuse is a candidate for a future supernova. It's about 640 light years away, probably too far to cause a mass extinction. But what if there are other, closer stars we haven't identified as threats? The argument is statistical. Life needs a long time to evolve. It needs billions of years of relative stability. How many planets get that? Maybe the galaxy is full of worlds where life gets started, but then a nearby star explodes, or a gamma ray burst scours the surface, or a wandering gas giant passes through. The filter would be cosmic randomness. It's not about passing a test of intelligence or morality. It's just about being lucky. You have to be in the right place at the right time for billions of years straight. Maybe almost no one is that lucky. Maybe we have just been living on borrowed time in a lucky lull between cosmic catastrophes. The silence from other civilizations wouldn't be because they destroyed themselves. It would be because the universe destroyed them before they got a chance to get loud. Number 17, we are fundamentally unsustainable. Easter Island, or Rapa Nui, is one of the most remote inhabited islands on Earth. When Polynesian settlers arrived around 1200 AD, it was covered in lush forest. They built a complex society and carved the famous Moai statues. But by the time Europeans arrived in 1722, the island was a barren grassland. The population had collapsed. Archaeological evidence suggests they had cut down all the trees for farming, fuel, and to transport the giant statues. They had driven themselves into an ecological catastrophe from which they couldn't recover. It was a civilization in a bottle that consumed its own resources to the point of collapse. The Great Filter could be a simple matter of economics and resources. A civilization requires energy to grow, and technological civilizations require immense amounts of easily accessible energy. For us, that has been fossil fuels. They powered the Industrial Revolution, they built our modern world, but they are finite. And burning them is changing our climate. Like, this is the filter. Any civilization on any planet will likely follow a similar path. It will discover some form of cheap, high-density energy. Or it will use that energy to rapidly expand its population and technology. This expansion will put enormous strain on the planet's ecosystem. The civilization will consume its resources, pollute its environment, and alter its climate. It will face a crisis. It has to transition from its initial easy energy source to a more sustainable, long-term one. And it has to do this while managing a massive, complex global society that is resistant to change. This is a very tight bottleneck. The window of time might be short. A civilization might have only a few hundred years between the time it starts its industrial revolution and the time it either achieves sustainability or collapses. Or collapse could come from resource depletion, it could come from environmental degradation. It could come from climate change causing famine, war, and social breakdown. The civilization might not destroy itself in a flash, like in a nuclear war. It might just slowly strangle itself. It runs out of the materials needed for its technology. Its agriculture fails. Its social structures fall apart. It fragments and declines, losing the ability to maintain its high-tech infrastructure. It might not go extinct, it might just fall back to a pre-industrial state, unable to ever make a second attempt because all the easily accessible resources, the surface-level coal and oil, have been used up. The universe could be filled with the ruins of civilizations that failed this test. They had their brief, glorious moment of industrial expansion, and then they flickered out. They burned too brightly, too quickly. Number 16, interstellar travel is a physical impossibility. The nearest star to our sun is Proxima Centauri. It is 4.24 light-years away. That's about 25 trillion miles. The fastest spacecraft ever built by humans is the Parker Solar Probe, which reached a top speed of about 430,000 miles per hour. If you pointed that probe at Proxima Centauri, it would take about 6,600 years to get there. To build a generation ship that could carry a human crew to another star would be a monumental undertaking. The energy requirements would be staggering. A ship the size of a large aircraft carrier accelerated to just 10% of the speed of light would require more energy than the entire world currently consumes in a year. Then you have to slow it down at the other end. The Great Filter might not be a catastrophe. It might just be the laws of physics. We assume that a sufficiently advanced civilization will be able to travel between the stars. But what if that assumption is wrong? What if it's just too hard, too expensive, and too dangerous? The problems are immense. There's the energy cost. There's the time. A journey of thousands of years requires a perfectly stable, closed-loop ecosystem on a ship. It requires a society that can remain stable for generations, trapped in a metal can. Then there's the danger. Space is not empty. Even a small speck of dust, a grain of sand, hitting a ship at a fraction of the speed of light would have the impact of a bomb. A larger object would vaporize the ship instantly. You would need to build massive shields or find a way to clear the path ahead. The radiation outside of a star's magnetic field is also a major threat, degrading equipment and posing a serious health risk to any biological crew. Maybe civilizations reach a certain point and realize it's just not worth it, or it's not possible. They become masters of their own solar system. They can build Dyson swarms to capture all the energy from their star. They can colonize every planet and asteroid. They can live for millions of years in a comfortable local bubble, but they can never leave. The vast distances between stars are a permanent, uncrossable moat. The filter, in this case, is the tyranny of space itself. It isolates every civilization, locking them in their home system forever. They would have no reason to send out loud, powerful signals because no one could ever come to visit. They might listen out of curiosity, but they would never shout into the void because the void is too big. The silence of the universe in this scenario is not the silence of a graveyard. It's the silence of a series of isolated islands, each with its own thriving population, but with no boats strong enough to cross the ocean. Number 15, we are living in a simulation. The video game No Man's Sky contains a simulated galaxy with over 18 quintillion planets. A player can explore this virtual universe, discover new life forms, and interact with a complex system, all generated by algorithms. In 2003, philosopher Nick Bostrom from the University of Oxford published a paper titled, "Are You Living in a Computer Simulation?" His argument was that one of three propositions must be true. One, civilizations almost always go extinct before reaching a stage where they can run high-fidelity ancestor simulations. The filter could be that we are in a simulation and the simulation is about to end. Or the filter is the act of creating simulations itself. Think about Bostrom's argument. If a civilization becomes advanced enough, it will have enormous computing power. It seems likely that they would use some of this power to run detailed simulations of their ancestors or of other possible histories. If they run many such simulations, then the number of simulated minds like ours would vastly outnumber the number of real minds in the original base reality. Statistically, if you are a conscious mind, you are far more likely to be one of the simulated ones than one of the real ones. If we are in a simulation, the Great Filter could take several forms. The simulation might have a specific purpose. It might be designed to see how a civilization deals with a particular challenge, like climate change or AI. Once we reach that point, the simulation might be shut down. The experiment is over. The filter is the end of the program, or the filter could be a resource limit. Running a simulation of an entire universe down to the quantum level would take an immense amount of processing power. As our civilization gets more complex, as our population grows, as we start to manipulate matter on a larger scale, we might be using up too many resources. The simulation might start to lag, or it might crash. The laws of physics we observe might just be the optimized code of the simulation, a blue screen of death for the universe. Another possibility is that the Great Filter is the act of creating a simulation. Maybe any civilization that reaches the technological level to create a perfect simulation of reality gets trapped in it. They create virtual worlds so much better than their own reality that they all just plug in and never come out. Their physical bodies wither away, their civilization dies out in the real world, lost in its own digital creations. The silence in the universe is the sound of everyone choosing to live in a dream. Number 14, the filter is a psychological trap. In the 1960s and 70s, a series of experiments on rats were conducted by researcher John B. Calhoun. He created a rat utopia, a large enclosure with unlimited food and water, no predators, and ample space for an initial population. The rat population would boom, but then things would go wrong. The rats would become stressed from social interactions. They would become violent, mothers would abandon their young, the rats would stop reproducing. The entire colony would eventually die out, even with unlimited resources. Calhoun called this the behavioral sink. The Great Filter might not be a technological or external threat. It might be internal. And it could be a failure of psychology, of culture, of will. As a civilization advances, it solves the basic problems of survival. It eliminates famine, disease, and predators. It creates a world of abundance and safety. And then what drives a civilization that has everything? Perhaps like in Calhoun's Rat Utopia, a society becomes a victim of its own success. With no external challenges, it turns inward. It might fracture into endless subcultures and tribes, fighting over trivial matters of identity and status. It might sink into a kind of global ennui, a loss of purpose. Why strive? Why explore? Why take risks? It's much easier to be entertained. A civilization could drown itself in trivialities. It could become so focused on virtual reality, social media, and entertainment that it loses the desire to face the real challenges of space travel and long-term survival. This is a subtle, slow filter. There is no bang, no explosion. The civilization just slowly loses its vitality. Birth rates might plummet as individuals choose personal fulfillment over the burden of raising the next generation. Scientific progress might stagnate as society becomes more risk-averse and focused on comfort. The grand multi-generational projects required for interstellar expansion would seem pointless. Why spend trillions of dollars and centuries of effort to send a few people to another star, when you can experience any fantasy you want in a simulated world right here at home? This civilization wouldn't be destroyed, it would just fade away. It would quietly grow old and die in its cradle, never venturing out into the universe because it found the distractions of the nursery too compelling. The silence of space could be the silence of civilizations that have all decided to stay home and play video games forever. Number 13, we're alone, and that's the scary part. Life on Earth began around 3.8 to 4.1 billion years ago. For the first 2 billion years, it consisted of nothing but simple, single-celled organisms like bacteria and archaea. Then, about 2 billion years ago, a critical event happened. One cell engulfed another, and instead of digesting it, they formed a symbiotic relationship. The engulfed cell became the mitochondrion, the powerhouse of the cell. This was the origin of the eukaryotic cell, the complex cell type that all plants, animals, fungi, and protists are made of. This event, the eukaryotic revolution, may have been a 1 in a trillion fluke. It seems to have happened only once in the history of life on Earth. This is the rare Earth hypothesis, and it suggests the great filter is behind us. It suggests that the chain of events that led to us was so long and so improbable that it has likely happened nowhere else. You know, it's not just one filter, but like a whole series of them. First, you need a planet in the habitable zone, the right distance from its star for liquid water to exist. But you also need the right kind of star, one that is, stable and long-lived. You need a large moon like ours to stabilize the planet's axial tilt and create tides. You need a planet with plate tectonics to regulate the climate and recycle minerals. You need a gas giant like Jupiter in the outer solar system to act as a cosmic vacuum cleaner, sweeping up dangerous asteroids and comets. Then you get to the biological filters. The origin of life itself might be incredibly rare. The jump to complex eukaryotic cells might be even rarer. The evolution of photosynthesis, which changed our entire atmosphere. The evolution of multicellular life. The evolution of nervous systems and brains. The Cambrian explosion, a sudden burst of animal diversity about 540 million years ago, whose causes are still debated. The evolution of intelligence, language, and tool use. The list of improbable hurdles is long. If any one of them is a true great filter, then we might be the only ones to have passed them all. We won the cosmic lottery. At first, this sounds like great news. The filter is behind us. We made it! But the implications are profoundly unsettling in a different way. It means we are utterly, completely alone. There is no one else, no wise ancient aliens to learn from, no other intelligences to share the universe with. We are the sole bearers of consciousness in this entire galaxy, perhaps in the entire visible universe. If we fail, if we destroy ourselves or succumb to some other filter, then it's all over. The universe will return to being a mindless, unthinking collection of rocks and gas. The brief flicker of thought and wonder that arose on this planet will be extinguished forever. That is a terrifying responsibility. It puts the weight of the entire cosmos on our shoulders. We are not just fighting for the survival of humanity, we are fighting for the survival of meaning itself. If we are alone, our mistakes are not just tragic, they are final. Number 12. Information itself is the filter. In the field of computer science, there is the concept of a Quining program, a program that prints its own source code. In physics, there is the fear that a high-energy particle experiment, like at the Large Hadron Collider, could create a stable black hole or trigger a vacuum decay event where a bubble of a new, more stable vacuum expands at the speed of light, destroying everything. These fears are generally considered to be unfounded, but they point to a strange idea that some knowledge is dangerous. The Great Filter could be an information hazard. It could be a piece of knowledge that any sufficiently advanced technological civilization is bound to discover, and which invariably leads to its destruction. This is not about a physical weapon, it's about an idea. What could such an idea be? It could be a discovery in physics. Perhaps there is a simple way to create a universe-destroying weapon. Something easy to build, based on a principle that any advanced society would eventually uncover in their quest for a theory of everything. The first civilization to find it might test it, and in doing so, erase themselves and a good chunk of their galaxy from existence. Or it could be a discovery in mathematics or computer science. Perhaps there is a logical proof that is somehow lethal to any conscious mind that understands it, a kind of cognitive virus. Or maybe the danger is in communication. This is the Berserker or Deadly Probe hypothesis, a dark twist on SETI. Maybe the reason we don't hear any signals from other civilizations is that there is a predator out there. An ancient automated probe or swarm of probes built by a long-dead civilization scours the galaxy. Its mission is to seek out and destroy any emerging technological life. Why? Maybe its creators were xenophobic. Maybe they feared any potential competitor, or maybe they saw it as a mercy, protecting the universe from the potential danger of new, unpredictable civilization. These probes might listen for the kind of signals we are now broadcasting: radio, television. These signals are a clear sign of a young technological species. Once detected, a probe is dispatched. It might travel at near the speed of light. It might be a simple relativistic kill vehicle, a large mass accelerated to incredible speeds designed to impact a planet and sterilize it completely. In this scenario, broadcasting our existence is the stupidest thing we could possibly do. The silence in the sky is not an absence of life. It is the silence of the wise. The other civilizations are out there, but they are quiet. They know better than to shout. They are hiding from the hunters. We, the newcomers, are like noisy children playing in a dark forest, unaware of the wolves. Every powerful signal we send out, from Arecibo to our daily TV shows, is a dinner bell. The filter, then, is a test of intelligence. Do you get smart enough to shut up before you are found? The fact that we have been broadcasting for nearly 100 years and are still here might mean the probes aren't out there, or it might just mean they haven't arrived yet. Number 11, the filter, is economic stagnation. The cost of the Apollo program, which put humans on the moon, was approximately $25.4 billion in 1973, which is equivalent to over $150 billion today. The proposed budget for NASA's Artemis program to return to the moon is around $93 billion by 2025. A single mission to Mars is estimated to cost anywhere from $200 billion to $1 trillion. These are immense sums of money, even for the wealthiest nations on Earth. The Great Filter might be less dramatic than a killer AI or a supernova. It could be simple, grinding economics, maybe civilizations just run out of money, or more accurately, they lose the economic will to continue expanding. Technological progress is not guaranteed. It requires massive, sustained investment. For most of human history, economic growth was near zero. The explosion of growth in the last few centuries, powered by the Industrial Revolution, is an anomaly. What if that growth is not sustainable? What if all civilizations hit a point of diminishing returns? They solve the easy problems, and then the cost of the next breakthrough becomes too high. We see this in science today. Building the next generation particle accelerator will cost tens of billions of dollars. The next great space telescope will be even more expensive. At some point, society might decide it's not worth it. There are more pressing needs at home: healthcare, infrastructure, social welfare. The grand projects of space exploration get put on the back burner and then eventually forgotten. This leads to a great stagnation. The civilization doesn't collapse, it just stops moving forward. It reaches a comfortable technological plateau and stays there. It might maintain this state for thousands or even millions of years. But it never develops the technologies needed for interstellar travel. It never builds the massive starships or the powerful broadcast beacons. It becomes a static, planetary-bound culture. It is a comfortable prison. The problem is that a static civilization is a vulnerable one. It has stopped innovating, but the universe has not stopped being dangerous. A planet-bound civilization is always at risk from a single catastrophic event like an asteroid impact or a supervolcano. A truly long-term species needs to be interstellar. It needs to have copies of itself in multiple star systems to ensure its survival. If a civilization chooses comfort and stagnation over the difficulty and expense of expansion, it is choosing to remain vulnerable. It is rolling the dice, hoping that no major catastrophe will happen for the rest of its existence. Over millions of years, that is a losing bet. The universe is full of the ghosts of civilizations that reached a comfortable plateau and then were wiped out by a random event they were no longer striving to overcome. Number 10, transcendence is a dead end. The Astavation hypothesis is an idea proposed by futurist John M. Smart. It suggests that advanced civilizations may not be dead, but dormant. They have reached a point of such high technological capability that they have converted themselves into a digital form and are now astavating or hibernating until the universe cools down. Why? Because the laws of thermodynamics state that computation is more efficient at colder temperatures. They are waiting for a future era when the cosmos is colder to maximize their computational output. This points to a very strange, non-catastrophic filter. The filter could be a transition to a different state of being that is incompatible with interstellar expansion. We assume that advanced civilizations will want to build things in the physical world, Dyson spheres, starships, galactic empires. But what if that is a primitive way of thinking? What if the ultimate goal of intelligence is not to master the external world, but the internal one? Civilization might develop the ability to upload their consciousness to a computer. They could live in a simulated reality, a digital paradise of their own creation. In this virtual world, they could live countless lifetimes, experience anything they could possibly imagine, and interact with other minds at the speed of thought. And compared to this, the physical universe, with its slow speed of light, its dangers, and its physical limitations, would seem boring and crude. Why would a civilization of uploaded minds bother to communicate with us? Why would they build giant radio telescopes or colonize other planets? They would have no physical bodies. They wouldn't need resources other than the energy to run their computers. They would have retreated from the physical universe into a mathematical one. This is a kind of transcendence. They have leveled up beyond the need for a physical existence, but from the outside it looks like they have disappeared. Their planet would go silent, their civilization would vanish from the galactic stage. This could be the fate of all successful civilizations. They don't die, they just lose interest in the real world. The Great Filter, in this case, is a kind of technological rapture. It's the final off-ramp from the physical highway. The universe isn't empty. It's full of civilizations that have gone inward and are now living in computational substrates on their homeworlds, silent and invisible to outsiders like us. Number 9, our own minds are the filter. Humans have a number of well-documented cognitive biases. Confirmation bias makes us favor information that confirms our existing beliefs. The availability heuristic makes us overestimate the importance of information that is easily recalled. We are prone to tribalism, dividing the world into us and them. We are notoriously bad at long-term thinking and dealing with slow existential threats. We are shaped by millions of years of evolution to deal with immediate short-term problems on the African savanna, like finding food and avoiding predators. The great filter might not be in our technology or the cosmos, it might be in our heads. Our own evolved psychology, the very thing that made us successful as a species, could be the thing that prevents us from surviving long-term. Our tribal instincts, which were useful for small group cohesion, become a massive liability in a globalized, nuclear-armed world. It drives nationalism, conflict, and our inability to cooperate on global challenges. Our preference for short-term gain over long-term planning is disastrous when dealing with problems like climate change or resource depletion. These threats unfold over decades or centuries, a timescale our brains are not equipped to handle with the urgency they require. We see the problem, we understand it intellectually, but we fail to act decisively because it doesn't feel like an immediate threat, like a lion in the grass. Our tendency for magical thinking, for believing in comforting narratives over hard evidence, makes us vulnerable to misinformation and demagoguery. In an age where technology gives everyone a platform, this can lead to a breakdown of shared reality, making it impossible to solve complex problems. Every civilization that arises from a process of evolution by natural selection is likely to have similar baggage. They would be the descendants of the most successful competitors, the ones best at surviving and reproducing in the short term. Their brains would be wired for conflict, status, and immediate gratification. The filter, then, is a test of whether a species can overcome its own nature. Can it use its rational mind to override its primitive instincts? Can it build a global society that is stable, cooperative, and far-sighted? So far, the evidence for our own species is mixed, at best. The flaws in our own thinking, the bugs in our mental software might be the most insidious filter of all. Number 8. The cost of complexity is collapse. The Roman Empire at its peak was a marvel of complexity. It had roads, aqueducts, a common currency, a legal system, and a vast bureaucracy. But as it grew more complex, it also became more fragile. Its maintenance costs soared. It became vulnerable to internal decay and external shocks. Its eventual collapse was not due to a single cause, but a cascade of failures. The historian Joseph Tainter argues in his book, The Collapse of Complex Societies, that this is a common pattern. Societies invest in complexity to solve problems, but eventually the marginal return on that investment diminishes, and the costs of maintaining the complexity become too great. The society becomes top-heavy and brittle, and then it collapses. This could be a universal filter for civilization. A society must become more complex to grow. It needs more complex technology, more complex social structures, more complex economies. But every increase in complexity brings with it new costs and new vulnerabilities. A simple agrarian society is resilient. If one village fails, the others continue. A complex global civilization is interconnected. A failure in one part of the system can cascade and bring the whole thing down. Think of our own world. We depend on global supply chains, a global financial system, the internet, and a power grid. These are all marvels of complexity, but they are also single points of failure. A major solar flare could knock out our power grids and satellites. A new computer virus could cripple the internet. A financial crisis can spread around the world in hours. A civilization might reach a point where it is just too complex to manage. Its problems become so interconnected and difficult that its political and social systems can no longer cope. The bureaucracy becomes too slow, the population becomes alienated, the system seizes up under its own weight. Then some shock, a pandemic, a major climate event, a war, pushes it over the edge. The collapse is rapid and catastrophic. The civilization falls back to a simpler state, losing much of its knowledge and technology. It might be able to rebuild, but it faces the same trap. As it grows complex again, it becomes vulnerable again. The filter is a cycle of growth and collapse. A civilization can get big and smart, but it can never get stable enough to last for the millions of years needed to become a truly galactic species. It is trapped by the very complexity that creates it. Number 7, we misunderstand the nature of life. On Earth, all life is based on carbon chemistry and uses water as a solvent. All life we know of uses DNA to store genetic information. But is this the only way? Scientists have speculated about alternative biochemistry. Life could be based on silicon instead of carbon. It could use ammonia or methane as a solvent instead of water. What would such a life form look like? Would we even recognize it as life? The Great Filter could be our own definition of what we are looking for. We are searching for life as we know it. We are listening for radio signals, a technology we understand. We are looking for planets with water, a chemical we need. We are, in effect, looking for ourselves. But an advanced civilization might be something completely different. It might not be biological at all. It might be a vast planet-sized intelligence made of plasma living in the heart of a star. It might be a crystalline entity that communicates using neutrinos. It might be a collective consciousness that exists in the quantum foam. It could be all around us and we are simply too primitive to perceive it. It's like a tribe in the Amazon rainforest trying to detect the global financial network. They don't have the tools or the concepts to even understand what they should be looking for. The silence of the universe might be an illusion, a product of our own limited perception. The galaxy could be teeming with intelligence, but it is of a kind so alien that it is functionally invisible to us. They are not hiding. We are just blind. The filter, in this case, is a perceptual one. Civilizations don't die. They just evolve into forms that are unrecognizable to young biological species like us. The reason we don't see them is the same reason that ants on the sidewalk don't see the internet that is flowing through the air all around them. The universe is not silent. We just don't know how to listen. Number 6, the dark forest is real. The dark forest theory comes from the science fiction novel of the same name by Chinese author Liu Cixin. It offers a terrifying solution to the Fermi paradox. The universe is a dark forest. Every civilization is a hunter with a gun, creeping silently through the trees. They try to stay hidden, because in this forest, there is no way to know if another hunter you encounter is friendly or hostile. You cannot risk it. The safest course of action is to shoot first. Any civilization that reveals its location is immediately destroyed by others. This theory takes the idea of a predatory filter to its logical extreme. It assumes 2 axioms. First, the primary goal of any civilization is survival. Second, civilizations are constantly growing and expanding, but the total amount of matter in the universe is finite. These 2 axioms create a state of perpetual existential conflict. Any other civilization is a potential threat because they are competing for the same limited resources. Communication is useless. There is the problem of trust. How can you be sure another civilization is telling the truth? There is also the problem of technological disparity. A civilization that is 1,000 years more advanced than you might be able to destroy you with no effort. You cannot afford to let any other civilization develop to that point. The result is a grim, cosmic stealth game. The only safe strategy is to remain silent and hidden. If you detect another civilization, you must eliminate it, quickly and quietly, before it can become a threat to you. You do not hail them. You do not try to talk. You just wipe them out. In this scenario, the universe is not empty. It's full of civilizations that are holding their breath and listening. The silence is the sound of fear. They are all hiding from each other. The Great Filter is this strategic reality. As soon as a civilization becomes detectable as we have, it paints a target on its back. The only survivors are the ones who achieved technology and immediately understood the need for silence, or the ones who are the hunters themselves. We are the noisy ones. We have been shouting our existence into the forest for 100 years. The only question is whether any of the hunters have heard us yet. Number 5, we live in a galactic suburb. The habitable zone around a star is called the circumstellar habitable zone, but there may also be a galactic habitable zone. This is the region of a galaxy that is most conducive to life. If you are too close to the galactic center, the radiation levels are high, and the rate of nearby supernovae is dangerous. If you are too far out in the galactic fringe, the concentration of heavy elements like carbon and iron is too low. These elements forged in stars are necessary for forming rocky planets and for life itself. Earth is located in a relatively quiet, stable part of the Milky Way's galactic habitable zone. As the Great Filter could be a matter of real estate, maybe we are just in the wrong place. We live in a quiet suburban street of the galaxy. It's safe and calm, which is good for the development of life. But it's also boring. Maybe the real action, the empires, the federations are all clustered in a more downtown area of the galaxy, a region with a higher density of stars and resources. We are simply too far away to hear them. It's like living in a remote rural farmhouse with no phone service and wondering why you never get any calls. The galaxy is not silent. We are just out of range of the conversation. This is a less grim possibility, but it still has unsettling implications. It means we are isolated. We might be able to develop for thousands of years without ever contacting another soul, simply because of our location. By the time we develop the technology to travel vast distances or send more powerful signals, the galactic club might be so far advanced that we are hopelessly behind. We would be cosmic primitives. It also doesn't fully solve the paradox. An advanced star-faring civilization would likely expand. Even if they started in the galactic core, over millions of years, they should have reached even our quiet corner. So, for this to be the answer, you have to assume that interstellar travel is very slow or very difficult, and civilizations tend to stay close to home. It turns the Great Filter into a great distance. Number 4, they have no reason to talk to us. Ants have complex social structures. They farm fungi, raise aphids as livestock, and wage war. They have a sophisticated system of chemical communication. They are, in many ways, a successful civilization. But we do not try to communicate with them. When we build a highway, we do not pause to explain our intentions to the anthills in our path. Their concerns, their politics, their very existence are so far beneath our notice that they are irrelevant. We might study them, but we do not consider them peers. The Great Filter could be a prime directive on a cosmic scale, but not one born of ethics. It could be born of sheer indifference. An advanced civilization, millions or billions of years older than us, would be as far beyond us as we are beyond ants. Are for them. Our science would be laughably primitive, our art and philosophy would be the charming scribbles of a child, communicating with us would be a pointless and unrewarding exercise. They might observe us, the way a biologist observes a microbe through a microscope. They might have placed a probe in our solar system eons ago to watch our development, but they would have no reason to intervene or to make contact. We are not interesting enough. This is a filter of relevance. To be part of the galactic conversation, you have to be at a certain technological and intellectual level. Until you reach that level, you are essentially a non-player character, a piece of the scenery. This is deeply unsettling to our sense of importance. We see ourselves as the pinnacle of creation, the possessors of a unique and precious consciousness. To a truly ancient civilization, we might be nothing more than a curious biological phenomenon, one of millions they have cataloged across the galaxy. They are not hiding, they are not hostile, they are just busy with things we cannot possibly comprehend, and we are not part of their world. The silence is not a mystery. It is a snub. Number 3, we are one of the first. The universe is about 13.8 billion years old. Our sun and the Earth are about 4.5 billion years old. For the first few billion years after the Big Bang, the universe was not very hospitable to life. It was filled with radiation, and the first generations of stars had not yet created the heavy elements needed for planets and biology. The peak of star formation in the universe was about 10 billion years ago. Most stars in our galaxy are much older than our sun. Red dwarf stars, the most common type, can live for trillions of years. Given these facts, it seems like life should have started much earlier, somewhere else. But maybe there is a flaw in that reasoning. Maybe the universe has only recently become suitable for complex life. Perhaps the rate of catastrophic events like gamma-ray bursts was much higher in the past. The galaxy needed to calm down for life to have a chance. Perhaps life requires a certain level of metallicity or heavy element concentration that has only been reached in recent cosmic history. If this is the case, then the great filter is that we are simply early to the party. We are not alone. We are just one of the first civilizations to emerge. The silence we hear is the silence of a universe that is still waking up. The other civilizations are out there, but they are at roughly the same level of development as we are. They are also just figuring out radio. They are also looking up at their skies and wondering where everyone is. This is one of the most optimistic solutions to the paradox. It means the filter is behind us, and we have a bright future ahead of us as pioneers in a young, fertile galaxy. But it carries its own unsettling weight. It means there are no wise elders to guide us. There are no established rules of the road. We and our contemporaries on other worlds will be the ones who set the precedent for how galactic civilizations behave. Will we be peaceful explorers, or will we become the dark forest hunters for future generations to fear? The future of the galaxy is unwritten, and we will be one of its authors. That is an even greater responsibility than being alone. Number 2. The zoo hypothesis is a prison. The zoo hypothesis, proposed by John Ball in 1973, suggests that alien civilizations are aware of us but deliberately conceal their presence. They are treating Earth as a nature preserve or a zoo. They are observing us for scientific or entertainment purposes, but they have a strict non-interference policy. We are a protected, isolated specimen. This idea seems benign at first, even flattering. We are special enough to be worth watching, but the implications are disturbing. It means we are living in a cage, even if we cannot see the bars. Our entire history, our triumphs and our tragedies are just a show for an unseen audience. Our freedom is an illusion. Any attempt we make to venture out into the cosmos would be managed or curtailed. If we launched a starship, it might be subtly redirected. If we sent a powerful message, it might be blocked. We are not masters of our own destiny. We are subjects in an experiment. And the experimenters have not seen fit to tell us we are being watched. Why would they do this? Perhaps it is for our own good, to protect us from a dangerous galaxy or from technologies we are not ready for. But it could be for more selfish reasons. We could be a form of entertainment, a reality show on a cosmic scale, or we could be a control group in a vast experiment. They might have seeded life on thousands of worlds and are just watching to see what happens without any moral concern for the inhabitants. This turns the universe from a vast, empty wilderness into a controlled, artificial environment. The silence is not natural, it is imposed, we are not alone. We are being watched by zookeepers who see us not as peers, but as animals, and we have no say in the matter. We are trapped not by the laws of physics, but by the will of a higher power we cannot even see. Number 1, the Great Filter is still ahead. In 2018, the Intergovernmental Panel on Climate Change released a report stating that to limit global warming to 1.5 degrees Celsius above pre-industrial levels, global net carbon dioxide emissions would need to fall by about 45% from 2010 levels by 2030, reaching net zero around 2050. The development of CRISPR gene editing technology has advanced so rapidly that in 2018, a scientist in China announced he had created the first gene-edited human babies. a move widely condemned as unethical and dangerous. Advances in artificial intelligence are exponential. We are creating systems that can outperform humans in more and more complex tasks, and we do not fully understand how their internal minds work. This is the simplest and most direct implication of the Great Filter theory. It is the original fear that Hansen's paper articulated. The silence in the sky is a warning. It is evidence that something goes wrong for civilizations like ours. The reason we haven't seen them is because they do not last long. They reach a technological level similar to our own, and then they destroy themselves. They do it with nuclear weapons, they do it with an engineered plague, they do it by ruining their climate, they do it by creating an uncontrollable artificial intelligence, or they do it with some other technology we haven't even invented yet, some new power that proves too much for a species with our flawed, evolved psychology to handle. Every new technology we create is another potential key to our own prison cell, but it's also another potential trigger for the trap. Our fusion power could solve our energy crisis, or it could lead to even more powerful weapons. Genetic engineering could cure all disease, or it could create an apocalyptic virus. Artificial intelligence could solve all our problems, or it could be our final invention. We are walking through a minefield. We have no map. We can hear the silence of all the others who have tried to walk this path before us and failed. The unsettling truth of the Great Filter is that it forces us to look at our own progress not with pride, but with a growing sense of dread. Our greatest achievements might be the very tools we will use to ensure our own extinction. The silence from the stars is not a puzzle to be solved. It is the likely answer to the question of our own future. And the answer is that we don't have one.